Okay, hello Year 12. I marked question 1 and question 4 from your 2-unit advanced task. So let's go through the answers. The first question was integrate x minus 1, x plus 1. So you expand it out and integrate the two parts and add the constant. It was 2 marks, so you basically lost 1 for each mistake you would have made on that one. The second one, we're integrating 6 minus 1 over the square root of x. So the first thing to do is to change this to a negative and fractional index, and then you integrate each part and add the constant. I didn't mind if you put a power of a half or a root x there, both were fine. Again, 2 marks, you sort of lost 1 for each mistake you made along the way. Okay, the next one, question C, we've got 2 over 3 minus 5x all to the power of 4. So what you do is you make this a negative index and you use the reverse chain rule. So you can see there we've taken the 2 out the front and we get 2/15 3 minus 5x to the minus 3, or you could have put in this as 3 minus 5x to the power of 3 on the bottom, both were fine, and don't forget the plus c. If you forgot a constant in any of those first 3 questions, you should only lose a maximum of 1 mark for a plus c, so if you forgot the constant multiple times, we only penalised 1 time for missing the constant. Okay, next question. We've got evaluate 3y minus 2 between 5 and 1 dy. So we integrate this between 5 and 1, sub in the 5, sub in the 1, subtract them obviously, and we get 28. It was 2 marks, and again you pretty much lost 1 mark for each error you made along the way. Okay, next one, we've got a graph of f of x, and it's made of these circular arcs here and here, and a couple of straight lines. We want to work out the definite integral between 10 and 0 of f of x dx. So the important thing to note is it's a definite integral, it doesn't actually say area. So what you do is you work out the total area above, which I'm shading here, and then you've got to subtract this area below here, and you can see you've got to work out the semicircle, the square and the triangle separately, not the semicircle, the quarter circle, the square and the triangle separately, or the quarter circle and a trapezium if you want, and then you take away this semicircle, and you can see there's the working out here. We've got there's the quarter circle, adding on the square, adding on the triangle, and taking away the semicircle, and it simplifies to 6 minus pi. Notice that you don't write units squared, okay? We don't want you to write units squared because it's not asking you for an area, it's asking you for a definite integral, and there's no reason to put this into your calculator. Exact values are probably better. So you got 1 mark for acknowledging that you needed to add together all of these parts, and you got 1 mark for the final answer, but you could have lost a mark if you called it a unit squared rather than an exact value, or for any kind of other careless error you made throughout here. Okay, next one. We've got if ds dt equals to 12t squared minus 6t plus 1, find s in terms of t given s equals to 4 and t equals to 1. So nice and easy. This is of course a first derivative, so we integrate it here, and don't forget the plus c, sub in the 1 and the 4, and then of course you sub it into here, and that tells you c is 2, and that's what you got your first mark for. But to get your second mark, you actually had to say s equals to 4t cubed minus 3t squared plus t plus 2, because it asked for s in terms of t, so you had to get all the way to this step here. Okay, next question, question 5. We want to work out what a is if we know that the integral of x between a and 1 is 4. So we integrate x and get x squared on 2 between a and 1 equals to 4. Sub in the a, sub in the minus 1, and sorry, I think I said 1, but I meant minus 1. Sub in the a, sub in the minus 1, and we work out a squared equals to 9, and then a equals to plus or minus 3, not just plus 3. Now, even though the a is on the top, we can still actually say a is minus 3. We can have a number, a limit on the top smaller than the one on the bottom if we want. So the answer is plus or minus 3. If you actually said, I know it's plus or minus 3, but I'm going to get rid of the minus 3 and just put in plus 3, I still gave you 2 marks because you actually remembered the plus or minus 3. But if you just wrote plus 3 and forgot the minus 3 with no explanation or reasoning, then you lost a mark. So you had to somehow acknowledge there was the plus or minus going to be there and show that you considered it to get the 2 marks for that one. Okay, next one. Now, this was a 1 mark question, so what we do is we've got a derivative here, d dx, and an integral x and 2, so we just let the derivative and the integral cancel out when we sub the x in, and we get 2 outside of the square root of 5x plus 1. Just note that there's no plus c here, because when I integrate this and sub the x in, I sub the x into here when I integrate it, and then when I get my constant by subbing the 2 in, the constant I get will actually disappear again when I differentiate it. So people who did this the long way, and some people did do it the long way, they worked out the whole thing, then they differentiated it and they got to the right answer. There was a lot of work for 1 mark, but they did get the mark. They realized there was no plus c, but you had to have this as your answer and nothing else because it was only 1 mark, right or wrong. Okay, next question. So we've got a soft drink can in the shape of a closed can, or I guess a closed cylinder, of height h and radius r. We know the volume's 380, show what h is, so it's a show question, so please actually show a step of working. And you know the volume of a cylinder is pi r squared, h is 380. So rearrange to get h and you get 380 over pi r squared. You did need to show the substitution into the formula and the rearrangement because you can't just copy this down because it's already there. You need to show how you got to it. Okay, next part. Show that the surface area S of the can is given by this. S equals to 2 pi r squared plus 760 on r. So you start off by saying the surface area of a cylinder is 2 pi r squared plus 2 pi rh. Sub in that h value that you got before and cancel out the pi's and cancel out one of the r's, and there you go. 2 times 380 is 760. Again, because it's a show question, anyone can just copy this down, so you needed to show step by step how you got to it to get the mark. Okay, on to the next part. Find the radius required to minimize the surface area of the can. So you had your expression, S in terms of R. The first thing you need to do is to differentiate this. So you got your first mark by differentiating this and getting 4 pi r minus 760 on r squared and saying, I know that this needs to equal to 0. So then you go, okay, when I get my first derivative and it's equal to 0, we go r cubed equals to 760 over 4 pi, just by timesing this equation by r squared, and r cubed equals to 190 over pi, and of course then we know that r equals to the cubed root of 190 over pi, or 3.925, because see, it did ask for 3 decimal places, so please do actually read the question. So your first mark was for differentiating and knowing to set it equal to 0. Your second mark was solving for the radius. And your third mark was testing that it was actually a minimum. So the test we've got in the answers here is we've got the second derivative, and we worked out the second derivative up here. So we get the second derivative, we sub in our value for the radius, and we work out that this must be greater than 0. Notice that I really did need you to actually sub in the number. So I needed you to actually show me subbing in this into the second derivative, or if you chose to do a table of values, I needed to see you actually subbing in the numbers for the table of values to prove it's a minimum. Okay, you can't just say, oh, this is negative, this is positive, so it's a minimum. You need to show the substitution into either the table of values or the second derivative to get full marks. Okay guys, thank you very much. That's it.